Hey folks, Bill Armstrong here. I thought we'd go through the practice test that I put on the website, the Course Compass site last week. It's the practice test, test 1. So let's get started. The first one, you were asked to consider an angle of theta equals 240 degrees. Now I'm not going to write out every problem on the practice test since you have a copy of it. I'm just going to be focused more on writing the solutions. The first thing I asked you to do was to sketch this angle in standard position. So remember, in standard position, you need your coordinate axes. The initial side of the angle is on the positive x-axis. And then since this is a positive angle measure, the rotation of the side would be in a counterclockwise rotation, and 240 degrees would terminate roughly there in quadrant 3. So there's your angle that measures 240 degrees. In part B, I asked you to convert this angle to an angle measured in radians. So to get the angle measurement in radians, remember that to convert from degrees to radians, you would multiply by pi over 180 degrees. That way the degree symbols would cancel out. And if you take 240 times pi over 180, you will see that that reduces down to 4 pi over 3. So the angle in radian measure is 4 pi over 3. The next thing I asked you to do was to determine a positive angle that is coterminal with the given angle. So if you were to give this positive angle coterminal to 240 degrees, if you were to do that in degrees, keep in mind you are simply going to take 240 degrees and add 360 degrees, a complete rotation. And that gives you, well, 240 plus 360 is 600 degrees. If you were to use the radian measure, which would have been okay, the radian measure would be 4 pi over 3 plus a complete circle, which is 2 pi. Now to add these two, you'd have to get a common denominator. 2 pi over 3 is 6 pi over 3. And if you go ahead and add those together, then 4 pi over 3 plus a 6 pi over 3, you would get 10 pi over 3 to be a coterminal angle to 4 pi over 3. Keep in mind, coterminal angles share the same terminal side. And in the degree world, you could just simply add 360 because 360 degrees are in a full circle. In the radian world, you would add 2 pi because 2 pi is a complete circle. Finally, for number 1, part D, you were asked to find a coterminal angle, coterminal with the given angle that had a negative measure. Well, similar to part C, what you would do, instead of, we're working in degrees, instead of adding 360, you would subtract 360 degrees. And that would give you negative 120 degrees as being an angle that would be coterminal to 240 degrees. Likewise, with radians, it would be 4 pi over 3 minus 2 pi. So 4 pi over 3 minus 6 pi over 3 gives you negative 2 pi over 3. So hopefully you had this sketch in 1A. Hopefully you have this as the converting the angle 240 degrees to radians. Hopefully in part C you either had 600 degrees as being a coterminal angle or 10 pi over 3 being a coterminal angle. And in part D, hopefully you had negative 120 degrees or negative 2 pi over 3 as being the negative coterminal angles. Okay, hey, in number 2, you were asked to find the area of a sector of a circle of radius 8 inches that's formed by a central angle of 43 degrees. And I asked you to round your answer to 2 decimal places. So if you're given the radius of the circle is 8 inches and the angle that's being made is 43 degrees, the only other bit of information you need to know is your formula for finding the area. So recall that the area is equal to 1/2 theta r squared, where r is the radius of the circle. And it's really important to remember that theta is our angle, but it's in radians. So the first thing we have to do here is we have to take our given angle, 43 degrees, and we have to convert that to an angle in radian measure. So we just take our 43 degrees and multiply it by pi over 180 degrees. Again, you'll get your degrees to cancel out. So we get our angle to be a 43 pi over 180. So now when we use area equals 1/2 theta r squared, we get the area of the circle to be 1/2 43 pi over 180 times the radius, which was 8 squared. And if you use your calculator and multiply all this out, you should get the area to be rounded to 2 decimal places, 24.02, and then we should include some inches or some units here. The units are square inches. Since we're talking about area, it's square inches. And that's number 2. Okay, for number 3, in number 3 you were asked, find the length of an arc that's intercepted by a central angle of 305 degrees in a circle of radius r equals 40 miles. And again, I asked you to round your answer to 2 decimal places. So here, we know theta is 305 degrees, and the circle has a radius of 40 miles. It's a big circle. Formula you need to find arc length. You need to know this formula. S equals r theta. Just like in your formula for area of a sector of a circle, again, theta must be in radians. So S will be the arc length, R is the radius of the circle, theta has to be an angle measured in radians. So just like in number 2, the first thing we need to do is to take our given angle, which is in degrees, and convert it to radians. So it's 305 degrees, and hopefully this is familiar. Multiply it by pi over 180 degrees, and you get the degrees to cancel out. And you'll end up with, when you do this multiplication, you're going to end up with 61 pi over 36. That's the measurement of this angle in radians. So now when we find the arc length, we get the arc length to be, well, the radius is 40. This is our angle, 61 pi over 36. And we use our calculator, multiply these together, and round it to 2 decimal places. We should get an answer of 212.93 miles. Folks, that's number 3. All right, folks. Hey, in number 4, you were given the cross-section of a camping tent and said that it forms a triangle. The slanted sides measure 7 feet, and the base of the tent is 8 feet. I asked you to find the height of the tent and round the answer to 2 decimal places. There's no way I'm going to try to draw this picture. That's a nice picture. I'm just going to draw the triangle. And the triangle looks something like this. That's the height you're trying to find. And you're told that the base is 8 feet. So 7 feet, 7 feet, 8 feet. If you know this is 8 feet, then we know this must be 4 feet and that must be 4 feet. And now you see in this triangle you have two right triangles. It doesn't matter which right triangle you use, the Pythagorean theorem will tell you that h squared plus a 4 squared is equal to 7 squared. Where h squared plus 16 equals 49, h squared equals 33. And then technically speaking, when we solve this equation and we take the square root of both sides, technically speaking, you have to remember to put in the plus or minus. But since we are talking about an actual triangle, the negative makes absolutely no sense whatsoever. The tent is not going down into the ground. So we get the height to be the square root of 33 feet. But I asked you to get a decimal approximation and to round it to two decimal places. So using your calculator to get the square root of 33, you should get the height to be about 5.74 feet. So that's a very friendly basic application of the Pythagorean theorem. And that's number 4. All right, in number 5, you're given a right triangle with an acute angle theta, and I asked you to determine exactly the 6 trig function values of theta. So the right triangle you were given looks something like this. Now, hopefully you picked up that with right triangle trig, the key to right triangle trig is SOHCAHTOA. The sine of an angle is equal to the opposite side, opposite to the angle over hypotenuse. The cosine of an angle is equal to the side that's adjacent to the angle over the hypotenuse. And then the tangent of an angle is equal to the side opposite the angle over the side that's adjacent to the angle. So here's our angle theta. The only thing we need to determine is the hypotenuse, and then we'll be able to get the 6 trig function values for theta. So we're going to get the hypotenuse. Let me just right now label it with a C by using the Pythagorean theorem. So we have an 11 squared plus a 4 squared equals c squared. 11 squared is 121. So we have 137 is equal to c squared. So the square root of 137 is equal to c. So let me go ahead and put the square root of 137 in there for the hypotenuse. And now it's just a matter of writing down the 6 trig functions. So here we go, the sine of theta. So sine is going to be opposite over hypotenuse. So it's 4 over the square root of 137. Cosine. Well, cosine is adjacent over hypotenuse. So the cosine of theta is adjacent, which is 11, over hypotenuse. So it's 11 over the square root of 137. And then finally, tangent. Tangent is opposite over adjacent. So tangent is the opposite side, 4 over adjacent, 11. So 4 over 11. Now for the other 3 trig functions, I'm going to make use of the reciprocal identities. In other words, cosecant is the reciprocal of sine. So I can write down the cosecant of theta is just the reciprocal of sine. Well, I just take the reciprocal of 4 over square root 137, and I get square root 137 over 4. Secant, well, secant's the reciprocal of cosine. So if I know cosine is 11 over square root 137, the secant will be the reciprocal of that. Square root of 137 over 11. And then finally cotangent. Cotangent is the reciprocal of tangent. So the cotangent will be the reciprocal of 4/11. So cotangent is 11 over 4. Let me make a quick comment here. A couple of you have sent me an email asking if, basically, if an answer like this would be okay. If it's okay to have a radical in the denominator, or if you have to go through the laborious, tedious, time-wasting process known as simplifying or rationalizing that denominator. I'm absolutely fine with that as an answer. I'm absolutely fine with that as an answer. If for some reason you just feel you have to rationalize the denominator, I'm not going to tell you don't do that. I mean, that's up to you. If you want to leave this as an answer, I'm more than happy. And that's number 5, folks. All right, in number 6, you're given that sine of theta is 7/25 and cosine theta is 24/25. And I ask you to determine exactly the values of the remaining 4 trig functions using identities. So, how I'd kind of start off. You know sine of theta. You know sine of theta is 7 over 25. And cosine theta is 24 over 25. So to finish this problem off, to get the remaining 4 trig function values of theta, please remember that tangent is nothing more than sine over cosine. So that's a 7/25 over 24/25, which you should reduce this down. I mean, that looks horrible. So 7/25 over 24/25, that will reduce down to 7 over 24. If you know sine, it's a piece of cake to get cosecant. Cosecant is nothing more than the reciprocal of sine. So the reciprocal is 25 over 7. Cosine is 24 over 25. If you take the reciprocal, that gives you the secant of theta. So secant is 25 over 24. And then finally, for cotangent, you just simply need to take the reciprocal of tangent. So the reciprocal of 7 over 24 is 24 over 7. And that's all there is to number 6. All right, hey, for number 7, I ask you to use identities to simplify sine theta, secant squared theta, cotangent squared theta. I ask you to simplify this down to one of the 6 basic trig functions. Now for me, the way I would attack this one, kind of straightforward. I start off with secant squared theta. Since I know secant is the reciprocal of cosine, secant squared will be the reciprocal of cosine squared. So I can rewrite secant squared as 1 over cosine squared theta. Now for cotangent squared theta, I'm going to use the quotient identity for it. Remember, cotangent is cosine over sine. So cotangent squared will be cosine squared theta over sine squared theta. So I rewrote secant squared as 1 over cosine squared, cotangent squared as cosine squared over sine squared. This is using a reciprocal identity. This is using a quotient identity. Now if I were to multiply these 3 fractions together, hopefully right now you would see, well, the cosine squareds cancel out, and we're left with a sine theta over a sine squared theta. Well, if you have a sine over a sine squared, that would reduce down to 1 over sine theta. And 1 over sine theta, well, the reciprocal of sine is cosecant theta. So what I gave you, the trig function that it reduces down to is cosecant theta. Now that's number 7. All right, folks, for number 8, the problem said a bird 330 feet above the ground spots a mouse. It spots the mouse at an angle of depression of 55.4 degrees. Find the line of sight distance between the bird and the mouse. All right, the first thing I'll try to do is draw a picture. I really suck at being an artist, so I'm not going to draw a fancy bird. I'm not going to draw a fancy mouse. I'm just going to say, there's the ground, and up here, well, that's the bird. It's the best I can do for a bird. And we know this bird is 330 feet above the ground. Okay, now the bird spots a mouse at an angle of depression of 55.4 degrees. Remember that an angle of depression or an angle of elevation, either one of those angles, are always with respect to a horizontal line. So if up here I were to imagine a horizontal line, notice it's parallel to the ground, the bird's angle of depression of 55.4 degrees, it's this angle right here, 55.4 degrees. That's the angle of depression. It's with respect to the horizontal. And right here's the mouse. So the question is, what is this distance? Well, you notice that you have a right triangle. Here are some other things that you should notice. If this angle here, the angle of depression, is 55.4 degrees, then this little angle right here that's inside the triangle must be 90 degrees minus 55.4 degrees. And the reason why is, here's a 90 degree angle. So this angle plus this angle must add up to 90 degrees. So to get the measurement of this angle, I do 90 degrees minus 55.4, and that gives me 34.6 degrees. This angle down here, well, two ways to look at that. I mean, it is 55.4 degrees. Way one to determine that it's 55.4 degrees is that the three angles of a triangle must add up to 180 degrees. So once you know this is 34.6, you can add that to 90, and then take that total and subtract from 180 to get 55.4 degrees. Or another way to look at it is an old property from geometry. This horizontal line up here and this horizontal line down here are parallel, and it's cut by this line. And when you have that happen from geometry, these two angles were called alternate interior angles, and alternate interior angles have equal measure. So in any event, this is the distance we're trying to find, the distance from the bird to the mouse. So let me call that distance, let me call it x. If I want to use this angle to determine x, I'm looking at this angle. I know the side that is opposite that angle, and I'm trying to find the hypotenuse. So the trig function that relates angle, opposite side, and hypotenuse would be sine. Sine of 55.4 degrees equals opposite over hypotenuse. And then if I multiply both sides by x and divide both sides by 55.4, sine of 55.4 degrees, I get this mess that x equals 330 divided by the sine of 55.4 degrees. And now if I use my calculator, I get an approximate value, 330 divided by sine of 55.4 degrees, of 400.91 feet. So the bird is about 400.91 feet away from the mouse. You could have, if you didn't want to use this angle 55.4, you wanted to use the angle 34.6, you could have done it that way as well. Except for here, notice that this angle 34.6, you would then know the side, 330, you would know the side that's adjacent to 34.6. You're still trying to find the hypotenuse. So the trig function that relates angle, adjacent side, and hypotenuse would be cosine. So you could have done cosine of 34.6 degrees equals adjacent over hypotenuse. And again, it has similar solution steps. Multiply both sides by x, divide both sides by cosine 34.6 degrees. And if you use your calculator, it's going to be no surprise. You're going to get x is about 400.91 feet. We better get the same result. Doesn't matter which way you solve it. And that, folks, that's number 8. All right, hey, for number 9, I gave you the point that's on the terminal side of an angle, and I ask you to determine exactly the 6 trigonometric function values of the angle theta. And the point that I give you is the point 3, -4. Well, if we first, if we just simply plot that point, down here's the point 3, -4. If I sketch the angle that goes through that point in standard position, notice it doesn't matter if we're talking about the positive angle or a negative angle. It doesn't matter if I'm talking about this as being theta or if I'm talking about that as being theta. No matter what I consider to be theta, this point is still on the terminal side of that angle. So we know what x is. X is 3. We know what y is. Y is -4. The only thing you have to really find is r. Now remember, r is the distance from the origin to your point. So if we remember that r equals the square root of x squared plus y squared, all we have to do is substitute 3 in for the x, -4 for the y, square the 3, square the -4, that gives us 9 plus 16, which is 25, and the square root of 25 is 5. We now have all the pieces to determine exactly the 6 trigonometric function values of theta. So we would have sine of theta, well, that's y over r. Y is -4, r is 5. So we get sine of theta is -4/5. Cosine of theta is x over r. Well, x is 3, r is 5, so we have cosine of theta is 3/5. And then tangent, think of tangent multiple ways now. Tangent, you can think of it as being y over x, which is -4/3, or you could use your quotient identity. Tangent is always sine over cosine. So you could have taken -4/5 over 3/5, and you're going to get the same thing. With that said, I'm going to get the remaining 3 trigonometric function values of theta simply by using our reciprocal identities. So if I know sine is -4/5, I then know cosecant is -5/4. Likewise, secant. Secant is the reciprocal of cosine. So I have secant is 5/3, and then cotangent is the reciprocal of tangent. So I have cotangent is -3/4. And folks, that's how you would do number 9. All right, hey, in number 10, you're asked, is it possible for an angle theta to exist such that the cosine of theta is positive and the secant of theta is negative? And then I ask you to explain. Well, quite simply, the answer is no. This isn't possible. It's not possible because cosine and secant are reciprocals. Secant is the reciprocal of cosine. So if cosine is positive, the reciprocal of a positive number must also be positive. So it's not possible for cosine to be positive and its reciprocal, secant, to be negative. So that's the short, sweet answer to number 9. No, and the explanation is because they're reciprocals. So that's number 9. Oh, I'm sorry, that's number 10. All right, hey, in number 11, you're asked to use identities to find exactly the 6 trig function values of theta, given sine theta is -4/7 and theta is in quadrant 3. Well, if you're given the sine of theta is -4/7, and you're also told that theta is in quadrant 3, so theta, this is the terminal side of theta, it's down here in quadrant 3. The first thing that I would look at is our mnemonic device. All students take calculus. And remember, this tells you that for any angle that terminates in quadrant 1, all 6 trig functions are positive. If your angle terminates out here in quadrant 2, sine will be positive. Well, as well as cosecant, because that's the reciprocal of sine. For any angle that terminates in quadrant 3, tangent is positive, as well as cotangent, because it's the reciprocal of tangent. And then if the angle terminates in quadrant 4, cosine is positive. And, well, secant would be positive as well, because it's the reciprocal of cosine. So you have cosine positive down here, tangent positive here, sine positive here, all of them are positive here. So how does that help me? Folks, if I ever know the value of sine, and I need to get the value of cosine, I'm going to use the Pythagorean theorem identity. It's called a Pythagorean identity. Cosine squared plus sine squared equals 1. I know sine is -4/7, so I can toss -4/7 in here for sine. And then I square it. Then I subtract 16/49 from both sides. Then I take the square root of both sides and I get cosine of theta equals plus or minus the square root of 33/7. But since theta terminates in quadrant 3, I know cosine has to be negative because tangent's positive in quadrant 3. So for this problem, we will use the cosine of theta is negative square root 33/7. I should be able to answer the question now. I should be able to list exactly the 6 trigonometric function values of theta. We were given sine of theta equals -4/7. We have determined that the cosine of theta is negative square root 33/7. Oops, it helps if I have my theta in there. Sorry about that. Tangent of theta. Well, we know tangent of theta is sine over cosine. We're using a quotient identity. So we get the tangent of theta it would reduce down to 4 over square root 33. And then cosecant, that's just the reciprocal of sine. Secant is just the reciprocal of cosine. And finally, cotangent, that's just the reciprocal of tangent. So identities kind of make this problem a pretty friendly, pretty straightforward problem. And that's number 11. All right, number 12. Number 12, no surprises here. You will see a blank unit circle. And you have to know all of the important points around the unit circle. This was in section 1.6, figure number 72. Quite simply, the unit circle is probably the most important feature in all of trigonometry because it tells you the coordinates of those points on the unit circle. Tell you the x coordinate tells you cosine, the y coordinate tells you sine. And if you know the cosine and you know sine, you can get the other 4 trig function values for free by using quotient identities and reciprocal identities. So you'll see something like this. It'll be a very nice looking circle on your test. I'm going to try to draw a circle now. It won't be that good. It won't be as good as the one you see on your test. But you will see a circle. That's not too bad for me. And these points will be labeled all the way around the unit circle. And when I say they'll be labeled A through whatever on the alphabet. This would be point A, this would be B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So you would have these points all the way around just labeled. And you have to tell me the coordinates of the points. So I will have, A. You will tell me the coordinates of point A. And you will say, well, point A has coordinates of 1, 0. B, and there will be a blank. You need to tell me the coordinates of point B. C, you'll need to write down the coordinates of C. All the way around, you see A through P. You fill in those coordinates of the points on the unit circle in the appropriate blank. Now I'll show you a little trick that I learned many years ago. I always got a little confused on which one of these points had square root 3 over 2 as the x coordinate and which one had square root 3 over 2 as the y coordinate. But I did notice that these 3 points here, all 3 of them were fractions. Both coordinates were fractions of all 3 of those points, and the denominator was a 2. So I developed the following counting trick. One, I had to know that this point was 1, 0, and I think that's pretty easy. I had to know that this point was 0, 1. That's pretty easy. In fact, all the way around where the unit circle intersects the coordinate axes, it's pretty easy to know what those 4 points are because the unit circle has a radius of 1. Now to get these 3 points, I kind of thought of this number 1 as being a fraction with a denominator of 2. And at first glance you'd say, well, that fraction would be 2 over 2. And you're correct. But I actually thought of it as being square root 4 over 2. Because square root 4 is 2. If I thought of that as being square root 4 over 2, then I got this x coordinate by counting down. It's square root 3 over 2. This point here, keep counting down. Square root 2 over 2. This x coordinate, keep counting down. It's square root 1 over 2. And notice this x coordinate is square root 0 over 2. So that's how I got those x coordinates. To get the y coordinates, I did the same thing except I counted up. This was 0 over 2, or square root 0 over 2, square root 1 over 2, square root 2 over 2, square root 3 over 2, and finally notice that 1 is square root 4 over 2. So that's how I got the points out here in quadrant 1. If I could fill this in, then all these other points cost me nothing. They are free. Because your unit circle, it's centered at the origin. You're going to have symmetry about the x, or the x-axis. You're going to have symmetry about the y-axis. I mean, heck, you're even going to have symmetry about the origin. But notice, to get the coordinates of this point, you can just use symmetry. These 2 points have to have the same y-coordinate. The x-coordinates are just opposite in sign. That's what symmetry means. So you get this to be a negative 1/2 square root 3 over 2. This point here, it's symmetric with this one. So it's negative square root 2 over 2, square root 2 over 2. This point, it's symmetric with that point out here in quadrant 1. So it's negative square root 3 over 2, 1/2. Likewise, to get these points down here, I can do symmetry about the x-axis. To get these points here, symmetry about the x-axis. And that's how you can fill in, that's how you can get all of those points on the unit circle. Very important structure. You need to know these points. You also will need to know, for these points, the radian measure of the angles that intersect the unit circle. That's just for trig in general. For number 12 on the test, you're just going to label these points on the unit circle. And hopefully you can finish the rest off. That's number 12, your unit circle question. All right, number 13. I asked you to determine exactly the 6 trigonometric function values for theta equals 2 pi over 3. And this is a basic unit circle question. So I need to know where 2 pi over 3 terminates. So 2 pi over 3 terminates about right there. I need to know on the unit circle the coordinates of this point, which you should have just filled in on number 12. The coordinates of that point will be negative 1/2 square root 3 over 2. And once I know the coordinates of that point, or negative 1/2 square root 3 over 2, I then know the x-coordinate is cosine, the y-coordinate is sine. So I can write down the sine of 2 pi over 3 is square root 3 over 2. The cosine of 2 pi over 3 is negative 1/2. And if I know those two, the other 4 really cost me nothing. Tangent. Tangent is sine over cosine. That's square root 3 over 2 over negative 1/2, which reduces down to negative square root 3. Cosecant is the reciprocal of sine. Secant's the reciprocal of cosine. And finally, the cotangent. Cotangent is going to be the reciprocal of tangent, which is negative 1 over the square root of 3. And that was 13. That was the last one on your practice test. I hope you're doing well with this material. I hope you feel confident for test 1. And I hope you found this video to be beneficial. Thanks for watching.